right, this is another episode of Science with a Guy in a Lab Coat. And hopefully, my audio is much improved this time. Today, I'd like to talk to you a little bit about the scientific method. That is the method that we use to find out if our hypotheses, our thoughts, and guesses about the world are correct or not. Um, this is the method that has been around since about the 1800s, and we found it's very effective. All scientific inquiry begins with a question. It begins with noticing that you don't know something. This can be a question that you pose to your parents if you're a student, or your teacher. It can be a question you pose to yourself. It can be any kind of question about the world, but it's got to be a question that you could actually test. And that's very important. That's a very important detail. And so after you find out that you have a question, you take a guess. You say, I believe that this will happen. And it's okay that you don't know what's going on, because like I said, the science starts with something you don't know. This guess, this belief, is your hypothesis. I believe this is going to happen, and here's how I'm going to test it. And then you tell about your method. Okay, so you've got a hypothesis. You've got to delineate your methods, and after that, you will make observations and come to a conclusion. Your hypothesis is that belief or guess about the world around you. Your methods describe how you're going to test it, and your observations are what you see, hear, feel, and otherwise notice. The facts, just the facts. If there are bubbles, say that there are bubbles forming. If the bubbles are warm to the touch, say that they are warm to the touch. If there is instead a solid that turns into a liquid, say that the solid turned into a liquid. If something exploded, say that it exploded, or at least that there was a violent reaction. So observations are just the facts. A lot of times when I tell students to make observations, they'll leap ahead to the conclusions. They'll say that it's because this chemical or that chemical, things that you can't possibly see with your eyes or know for factually correct. Um, those things are best left for the conclusion. Anything that you don't absolutely know for certain, anything that is not a verifiable, proven fact, is part of your conclusion. Um, so you have your hypothesis, that guess, that belief. Your methods delineate how you're going to prove or disprove that belief. Your observations are the facts, the things that actually happened. And then the conclusion is what you believe now after you've done that experiment. Okay? So a conclusion always has to be something that's entirely logical given what you just saw and heard and felt. It has to be something that is entirely possible. It doesn't have to be 100% true. It has to be something that is not proven wrong, and that explains exactly what happened in a very reasonable way. If somebody else thinks that your conclusion is wrong, then they will take the next step, the fifth step of the scientific process, which is peer review. Peer review is two words. Peers are the people who are not better than you, but they're at your level. And then review is review. Well, you know what review is. So it's when somebody else takes your work and they review it. In the scientific world, they take your experiment and your conclusion, and they say, my hypothesis is that this conclusion is wrong, or that this conclusion is right. And then they test it. And after they test it, they come to their own conclusion. My conclusion is that I can't prove them wrong. Or my conclusion is that I just proved them wrong, so what's up now? And then they have to come up with their own conclusion if that's the case. And that is peer review. In most science classes that I've seen, we haven't done much peer review. I'm going to try to change that in my class. If you're one of my students and you wish to turn in a an experiment, then it must have those first four things. It has to have a hypothesis. It has to have methods that tell how you tested this hypothesis. It has to have observations, which are just the facts, and it has to have a conclusion, which is entirely reasonable and not proven wrong by your own experiment. And also, there's one more thing that I require of all experiments that turned in. We go by the ancient words of internet wisdom: PIX or it didn't happen. Okay, so you need to prove that you not only that you are willing to do and put your hypothesis into the test, you need to prove that you actually did the thing that you said you were going to do in your methods. Um, so that's the scientific method. Thank you for watching. Rate this video, or like it or dislike it, especially if you like it. And let me know in the comments below if this helped you with your science class, or if it didn't help, or there's something else that you want that would help. Thanks for watching as always, and make sure you subscribe to my channel for more updates.